First, we need to simplify the trigonometric terms in both the numerator and the denominator. In the numerator, we have cosec x plus sin x. Cosec x can be written as 1 over sin x and sin x remain as sin x over 1. Taking the common denominator in the numerator, which is sin x, we get 1 plus sin squared x over sin x. In the denominator, we have cosec x times sec x plus tan x times sin squared x. Using trigonometric identities, cosec x equals 1 over sin x, sec x equals 1 over cos x, and tan x equals sin x over cos x. We can rewrite the denominator. Then we have 1 over sin x times 1 over cos x plus sin x over cos x times sin squared x. Now we can get a common denominator as sin x times cos x. Then we have in the numerator 1 plus sin cube x into sin x sin to the power of 4x over sin x cos x. Next, let's substitute the simplified expression for the numerator and denominator into our integral question. After substitution, we proceed with simplification. We can cancel out denominator of the numerator term sin x and denominator of the denominator term sin x. Denominator of the denominator can effectively be written as the numerator when simplified. Now we have in the numerator 1 plus sin squared x times cos x, in the denominator 1 plus sin to the power of 4x. In this integral, we observe that the expression contains multiple sin x terms but only one cos x term. Therefore, the function can be treated as a function of sin x with an additional cos x term present. To simplify, we need to eliminate the cos x term by using an appropriate substitution. Let us substitute u equals sin x. Differentiation with respect to x. Differentiation of the u value we can write as du over dx. Differentiation of the sin x equals cos x. Then we can cross multiply denominator value dx and we can subject dx value as du over cos x. Now let's proceed to the integration part. Instead of sin x, we substitute u equals sin x. Similarly, for dx, we substitute du over cos x. After substitution, the integral becomes 1 plus u squared over 1 plus u to the power of 4 times cos x du over cos x. Next, we cancel out cos x from the numerator and the denominator. Then we have 1 plus u squared over 1 plus u to the power of 4. Integral 1 plus x squared over 1 plus x to the power of 4 equals 1 over root 2 times tan inverse x minus 1 over x over root 2. This integral result has already been discussed on this channel. If you would like to revisit the detailed derivation of this integral, you can find it in the description. In this case, the integral 1 plus u squared over 1 plus u to the power of 4 can be expressed as 1 over root 2 tan inverse within bracket u minus 1 over u over root 2. Instead of u, we substitute back u equals sin x. This gives 1 over root 2 tan inverse sin x minus 1 over sin x over root 2. Finally, we need to include the arbitrary constant of integration, denoted as capital C. This ensures the generality of the solution for the indefinite integral. In this question, it is given that when x approach pi over 2 from negative side, the value of fx equals 0. Using this condition, we can determine the value of capital C. Let's substitute fx value for our limit. When x approach to pi over 2 from negative side, we can write 1 over root 2 tan inverse. Instead of x value, we can substitute pi over 2 minus 1 over sin pi over 2 over root 2 plus c. Sin pi over 2 equals sin 90 degree. Sin 90 equals 1. Then we can substitute sin 90 as 1. Then we have 1 over root 2 tan inverse 1 minus 1 over 1 over root 2 plus c. 1 over 1 equals 1, 1 minus 1 equals 0. Then we have 1 over root 2 times tan inverse 0 plus c equals 0. Tan inverse 0 equals 0. Therefore, capital C value should be equal to 0. Then we can rewrite fx as fx equals 1 over root 2 tan inverse sin x minus 1 over sin x over root 2 plus 0. We need to calculate f pi over 4. Substituting x equals pi over 4 into the function, we can get the result 1 over root 2 tan inverse sin pi over 4 minus 1 over sin pi over 4 over root 2 plus 0. Sin phi over 4 means sin 45 degree. Sin 45 equals 1 over root 2. Let's substitute instead of sin phi over 4, 1 over root 2 value. We can simplify these values and get the result minus 1 over 2. So, if pi over 4 value equals 1 over root 2 times tan inverse minus 1 over 2.